well, it's not all lies.
All of
There's
it.
some lies.
I found that too.
Lost civilization in Grand Canyon was, wait, Egyptian?
In the world of archaeological mysteries, there are few stories as tantalizing as the quest to uncover hidden ancient civilizations. For years, enthusiasts and researchers alike have been captivated by the idea of uncovering the secrets of a long-lost world concealed beneath the Earth's surface.
This is a very neglected area of the world as far as deep and ancient archaeology goes.
And now, in an incredible twist of fate, we have received shocking news of an ancient civilization that has been finally found, right beneath the awe-inspiring Grand Canyon. Join us on a journey into the depths of the Grand Canyon, where we uncover the incredible secrets of this newfound ancient world, a revelation that has sparked excitement and intrigue worldwide. The Grand Canyon's beauty has always amazed explorers, geologists, and historians. But hidden beneath its rocky surface, a recent revelation has astounded experts in the world. An extraordinary discovery of an ancient civilization, unseen for centuries, is set to change our view of history. The Grand Canyon, located in Arizona, United States, is a steep-sided canyon carved by the Colorado River. It stretches for 277 miles in length, spans up to 18 miles in width, and reaches a depth of over a mile. This majestic canyon and the surrounding rim are encompassed within various protected areas, including Grand Canyon National Park, the Kaibab National Forest, Grand Canyon Parashant National Monument, the Hualapai Indian Reservation, the Havasupai Indian Reservation, and the Navajo Nation. The broader region is part of the Baaj Nwaavjo I'tah Kukveni Ancestral Footprints of the Grand Canyon National Monument. President Theodore Roosevelt played a pivotal role in advocating for the preservation of the Grand Canyon area and frequently visited it for hunting and to revel in its breathtaking scenery. The geological history of the Grand Canyon spans nearly 2 billion years, with the Colorado River and its tributaries carving through layers of rock as the Colorado Plateau underwent uplift. While there is some debate among geologists about the exact timeline, recent studies suggest that the Colorado River established its course through the area approximately 5 to 6 million years ago. Over this time, the river's erosive forces have shaped the canyon by deepening and widening it. The Grand Canyon has been home to Native American communities for millennia, with settlements established within the canyon and its numerous caves. The Pueblo people considered the Grand Canyon a sacred place and made pilgrimages to it. The first European known to have encountered the Grand Canyon was Garcia López de Cárdenas from Spain, who arrived in 1540. The Grand Canyon is a river valley located within the Colorado Plateau, revealing layers of uplifted Proterozoic and Paleozoic rock strata. It is part of the Colorado Plateau Province, one of 6 distinct physiographic sections within this region. Although not the world's deepest canyon, with Kali Gandaki Gorge in Nepal holding that distinction, the Grand Canyon is renowned for its vast size, striking visual impact, and its intricate, colorful landscape. From a geological perspective, it holds great significance due to the well-preserved and exposed ancient rock layers in its walls, which provide insights into the early geologic history of North America. The formation of mountains and the subsequent uplift of the Colorado Plateau led to the displacement of these sedimentary layers, raising them thousands of feet above their original positions. This uplift also resulted in increased precipitation within the Colorado River drainage area, but the Grand Canyon region remains predominantly semi-arid. The elevation change across the Colorado Plateau is not uniform, and the Kaibab Plateau, which the Grand Canyon intersects, stands over 1,000 feet higher at the north rim compared to the south rim. This topographical variation influences the direction of water runoff. Most of the runoff from the north rim, which receives more rain and snow, flows towards the Grand Canyon. Conversely, much of the runoff from the plateau behind the south rim drains away from the canyon, following the general slope. Consequently, the north side of the canyon features deeper and longer tributary washes and canyons, while the south side displays shorter and steeper side canyons. Now, in terms of temperature, what's the difference between the north rim and the south rim? The north rim experiences cooler temperatures compared to the south rim, primarily due to its higher elevation, averaging around 8,000 feet. Both rims typically receive substantial rainfall during the summer. However, access to the North Rim, primarily through State Route 67, is constrained in the winter due to road closures. Can life survive in the Grand Canyon? There is evidence that life can survive in the Grand Canyon as it is home to an estimated 1,737 distinct species of vascular plants, 167 species of fungi, 64 species of moss, and 195 species of lichen. The remarkable diversity of plant life within the Grand Canyon is primarily attributed to the substantial elevation change of 8,000 feet from the Colorado River to the highest point on the North Rim. Within the boundaries of the Grand Canyon Park, there are 12 unique plant species found nowhere else, while only a mere 10% of the park's flora consists of non-native species. 63 plants within this region have received special recognition from the U.S. Fish and Wildlife Service. The western segments of the canyon are influenced by the Mojave Desert, the eastern portions are characterized by Sonoran desert vegetation, and both rims are adorned with ponderosa and pinon pine forests. The canyon's natural seeps and springs that emerge from its walls provide a habitat for 11% of all plant species found within the Grand Canyon. In addition, the canyon acts as a bridge between the eastern and western environments, offering suitable habitats along its length. On the other hand, it can also serve as a genetic barrier for some species, such as the tassel-eared squirrel. Furthermore, the orientation or the direction a slope faces significantly contributes to the diversity found in the Grand Canyon. North-facing slopes receive approximately 1/3 of the usual sunlight, resulting in plant life resembling that of higher elevations or more northern latitudes. In contrast, south-facing slopes bask in full sunlight and are adorned with vegetation typical of the Sonoran Desert. Within the Colorado River corridor, you can find a total of 90 different species of mammals. Among them, there are 18 types of rodents and 22 species of bats. The Grand Canyon is home to several significant ecosystems, and its remarkable biological diversity can be explained by the presence of 5 out of the 7 life zones and 3 out of the 4 desert types in North America. What are these 5 life zones? These 5 life zones include the Lower Sonoran, Upper Sonoran, Transition, Canadian, and Hudsonian, essentially spanning the ecological spectrum from Mexico to Canada. The primary factors responsible for shaping the various life zones and communities in and around the canyon are the variances in elevation and the resulting climatic differences. Grand Canyon National Park boasts a remarkable 129 distinct vegetation communities, and the composition and distribution of plant species are influenced by a combination of climate, geomorphology, and geology. At the base of the canyon, where the Colorado River flows, one can find an incredible variety of life. This part of the canyon provides a lush, riparian habitat that supports a significant portion of the park's biodiversity. Riparian areas with their reliable water supply offer critical resources for many species. Birds are prominent inhabitants of the Grand Canyon, with over 350 species recorded. Raptors like the peregrine falcon and golden eagle soar through the skies, while crows, ravens, and vultures are often seen scavenging along the rim. The southwestern willow flycatcher, a threatened species, is another remarkable bird that nests in the canyon's riparian areas. What about the water creatures? The river itself teems with life, including native fish like the humpback chub, razorback sucker, and bonytail. These fish have adapted to the challenging environment of the Colorado River, where temperature fluctuations and swift currents are the norm. Conservation efforts aim to protect these unique species and restore their populations. Beyond the water's edge, there are mammals specially adapted to life in the canyon. The bighorn sheep, a symbol of the American West, skillfully navigate the steep cliffs and rugged terrain. Other mammals include the elusive mountain lion, bobcat, and mule deer. The Grand Canyon is also home to many smaller mammals, such as ringtail cats, foxes, and several species of bats. In the scrubby vegetation of the canyon, various reptiles and amphibians find refuge. Gila monsters, venomous but rarely encountered, are some of the canyon's most iconic reptiles. They share the terrain with collared lizards, rattlesnakes, and numerous species of frogs and toads. These creatures face the challenge of adapting to both extreme temperature fluctuations and limited water sources. What are the geologic origins of the Grand Canyon? The Grand Canyon is an important part of the Colorado River Basin, which has taken shape over the course of the past 70 million years. Over the span of more than 150 years, scientists have accumulated data, proposed fresh concepts, and engaged in sometimes heated debates about the geological origins of the Grand Canyon and the Colorado River. The formation of the Grand Canyon and the Colorado River is likely the result of a multifaceted history, involving numerous factors and geological processes that have interacted across various times and locations. In a recent controversy surrounding the age of the river, researchers have challenged previous estimates that suggested the canyon's age to be around 6 million years. This research has generated substantial debate because it proposes a significant departure from the previously widely accepted scientific consensus. In a study from 2008, Victor Polyak explored caves near the Grand Canyon and dated their origins to approximately 17 million years ago using uranium lead dating on calcite deposits found in 9 caves throughout the canyon. In another 2008 study, Rebecca Flowers presented findings based on apatite thermochronometry, indicating that parts of the Grand Canyon reached depths similar to their current depth nearly 20 million years ago. In a subsequent study published in the journal Science in 2012, she suggested that the western section of the Grand Canyon could be as old as 70 million years. The prevailing scientific consensus indicates that the Grand Canyon consists of multiple segments, each forming at distinct times and eventually merging to create the waterway now navigated by the Colorado River. Among the central segments, the Hurricane segment took shape around 50 to 70 million years ago, while the eastern Grand Canyon was carved approximately 15 to 25 million years ago. On the other hand, the Marble Canyon and westernmost Grand Canyon segments at the extremities of the canyon were sculpted in the relatively recent span of 5 to 6 million years. The primary geological exposures in the Grand Canyon encompass a wide age range, from the ancient 2-billion-year-old Vishnu schist at the base of the inner gorge to the 270-million-year-old Kaibab limestone on the rim. Notably, there is a gap of roughly 1 billion years between 1.75 billion and 1.25 billion years ago, signifying a protracted period with no deposited materials. Subsequently, from 1.25 billion to 730 million years ago, sporadic sediments began to form the Grand Canyon supergroup. Many of these formations were deposited in warm, near-shore environments, including beaches and swamps, as the shoreline repeatedly advanced and receded over the edge of a proto-North America. An important exception is the Permian Coconino sandstone, which contains substantial geological evidence of Aeolian sand dune deposition. Certain portions of the Supai group were also deposited in non-marine settings. The impressive depth of the Grand Canyon, particularly the height of its strata, the majority of which originated below sea level, can be attributed to an uplift of the Colorado Plateau by 5,000 to 10,000 feet, commencing approximately 65 million years ago during the Laramide orogeny. This uplift steepened the stream gradient of the Colorado River and its tributaries, subsequently increasing their velocity and their ability to erode rock. During the Ice Ages, changes in weather conditions led to an augmentation of water in the Colorado River drainage system. Because of this, the ancestral Colorado River responded by intensifying its channel's erosion, making it both faster and deeper. Around 5.3 million years ago, a pivotal transformation occurred in the base level and path of the Colorado River, or its ancestral counterpart. This transformation was driven by the opening of the Gulf of California, which resulted in a lowered base level for the river. This significant development accelerated the erosion process and was responsible for carving nearly the entirety of the Grand Canyon's current depth by 1.2 million years ago. The formation of the canyon's terraced walls is attributed to differential erosion. In the period spanning from 100,000 to 3 million years ago, volcanic activity deposited ash and lava across the region, at times entirely obstructing the river's course. These volcanic rocks represent the youngest geological formations within the canyon. The Grand Canyon's plant life is equally diverse. The elevation change from the canyon floor to the rim results in a variety of ecosystems, each with its unique flora. The cacti and yuccas of the arid desert environment blend seamlessly with the pinon and juniper woodlands found at the higher elevations. Aspens, willows, and ponderosa pines also make their homes in the canyon, and each species plays a vital role in the local ecosystem. Although the plant and animal life in the Grand Canyon is remarkable, it also faces significant challenges. Invasive species, habitat loss, and a changing climate threaten the delicate balance of this ecosystem. Conservation efforts strive to protect and restore the unique species that depend on the canyon's diverse habitats. Now, what ancient civilization was found under the Grand Canyon? In 1909, an intriguing story made headlines in the Arizona Gazette, suggesting the discovery of an ancient Egyptian civilization within the Grand Canyon on April 5th. According to the article, two scientists named J.W. Kincaid and J.D. Huffaker came upon an extensive network of caves brimming with Egyptian relics, such as statues, copper weaponry, and granaries filled with seeds. These caves were described as spacious enough to accommodate up to 50,000 people, boasting an architectural style previously unseen in North America. Covering a vast expanse of 277 miles in length, up to 18 miles in width, and descending to depths of 1 mile, the Grand Canyon is celebrated as one of the most breathtaking and awe-inspiring locations in the United States. Navigating through the canyon can be challenging, making it a conceivable place to conceal or uncover historical artifacts. The account of this lost Egyptian civilization hidden within the Grand Canyon has stirred excitement among history enthusiasts. Nevertheless, skepticism surrounds its authenticity. Curiously, the Smithsonian Institution, renowned for its extensive collection of ancient Egyptian artifacts, has no records of individuals named Kincaid or Huffaker or any documentation of the discoveries they purportedly made. The whereabouts of these mysterious caves and their fate following the initial report remain unknown. Some speculate that the story might be a mere fabrication concocted by the Gazette to boost its readership. According to some other researchers, these caves might have existed but were gradually eroded by natural processes over time. Lastly, there are those who speculate that the artifacts could be legitimate, but were possibly transported to the Grand Canyon by Native Americans through trade or other interactions with Egyptians. Regardless of the story's veracity, it undeniably presents a captivating mystery that continues to capture people's imaginations. The descent of ancient Egypt initiated in the 7th century BCE with its conquest by the Assyrians. Although Egypt eventually regained its sovereignty, it never managed to reclaim its previous grandeur. The empire continued to wane, and by the 1st century CE, Egypt had transformed into a Roman province. The erosion of Egyptian historical records is a multifaceted matter. One facet pertained to the destruction of numerous ancient Egyptian monuments by foreign invaders. Another facet was the gradual decline of the Egyptian language, rendering ancient Egyptian texts less comprehensible and accessible. Despite the forfeiture of a substantial portion of its historical heritage, Egypt remains a captivating and enigmatic land. The account of the lost Egyptian civilization concealed within the Grand Canyon represents just one of numerous enigmas awaiting resolution. So, what does the Grand Canyon have to do with ancient Egyptian civilization? The intriguing connection between the Grand Canyon's geological landmarks and ancient Egyptian and other mythologies is a reflection of the canyon's rich history and the tapestry of influences that have shaped its nomenclature. While the names Isis Temple and Horus Temple allude to Egyptian deities, they represent just a fraction of the cultural diversity embedded in the Grand Canyon's landscape. Clarence Dutton, the 19th century geologist responsible for naming many of these landmarks, captured a wider array of mythological and legendary references. One notable example is Apollo Temple, paying homage to the Roman god of light, a nod to the classical world that once held sway in the Mediterranean. The inclusion of Apollo Temple reflects the canyon's role as a canvas upon which various cultures and civilizations have left their marks. Delving deeper into the canyon's nomenclature, one can discover references to Arthurian legend, an intriguing bridge between Celtic mythology and the vast American landscape. Names like Guinevere Castle and Galahad Point offer glimpses into the enduring power of Arthurian tales, which have captivated imaginations for centuries. The appearance of these names in the Grand Canyon showcases how history intertwines and leaves its indelible mark in unexpected places. These distinctive names serve as historical threads that weave through time, inviting exploration and study. They are more than just labels. They are windows into the human fascination with myth, legend, and the marvels of nature. Each name, whether tied to an Egyptian goddess or a knight of the Round Table, carries a piece of our collective past and underscores the complex tapestry of human history etched into the Grand Canyon's rocky heart. We hoped you liked this video. If you did, please click the like button, drop a comment below, and share. Don't forget to subscribe too. Thank you for watching.